Hey, Governor, your experimental water is ready.
Why? Would you be a darling and mix some copper sulfate for me?
No, I won't.
Yeah, I'll do it myself.
Yeah, you do that.
Hello everyone. Today we are going to see if we can make a hot plate and a stirrer. As you can see, I have this piece of wood right here, and to hold the motor I have cut out this hole. And I did a pretty bad job at it. So to cover my shameful and horrific job, I will be using this 3D print. So if I don't see it, it's not there. Okay, and for the heater part, I will be using 5 of these heater cartridges. Each of them, as you can see, is 370 watts. So 5 of them in parallel would be 1850 watts. So to hold these heater cartridges, I made this custom aluminum housing. So these get very hot, so hot that they will actually weld the aluminum to itself. So you have to be very careful with that. So now let's move on to the circuit. Okay. For controlling the heater, you got your SSR. I couldn't take out this screw. As you can see, it's just all stripped away. So I just soldered this wire. This is not a good idea, and this is just a temporary measure, hopefully. To hold all of these PCBs, I'm using these 3D printed feet here. So this is your 12-volt power supply. This is your L298N motor driver. There is a very good reason for using this because it also provides 5 volts to the ESP32, and it's just very good at driving the motors. So you can forward the motor, reverse the motor very easily. It would be a bit hard to do it with the MOSFET because you have to solder everything together and all of those things. So just easier. So you got your thermistor here. A thermistor, your rotary encoder, and where's Oled LCD, and potentiometer for controlling the speed of motor. I thought about using the rotary encoder for controlling the motor also, but having a separate controller for the motor is just a good idea, I guess. This is what it looks like after putting everything together. All the code and 3D models will be available in the description on GitHub. For thermistor, I got this thermometer from a dollar store and I broke it off, and I'm just gonna put my thermistor inside it and push it all the way. This is for food safety, and I'm gonna clean it up so it looks dirty now. Let's talk about motor first. The motor runs at 20 kilohertz to prevent that annoying loud whine. You might have to adjust the minimum duty cycle at which your motor runs. This one runs at 20% minimum. So this feels nice. I like it. I'm gonna cover it with this, a 3D printed cover. Now let's talk about heater. I have placed these 2 pieces of ceramic fiber paper at the bottom to insulate it. You might smell something for the first time, but that's just the organic binder burning off. I have put these brass standoffs here at all of the 4 ends to keep the top perfectly leveled. I have also included code for auto-tuning the PID, but I like to tune it manually because it gives you the better understanding of the behavior of your heater. You can adjust the set point with this rotary encoder here. Just 1 second. And as you can see, the PID is working. Just gonna turn it off. And it's off. You might ask how the PID works with SSR, which is a zero cross switching relay. So for DC voltage, making the PID work is easy. You can just adjust the duty cycle and it will vary the output power. For AC, the process is a little bit more involved. The circuit that I'm using does not require any zero cross detection circuit. So for AC, you have your AC waveform. To make the PID work, what we can do is turn on the relay for one whole cycle or maybe even half the cycle, and then turn it off for whatever many other cycles, and then turn it back on again. So what I've done is, so the PID library will give you the output power, for example 20% based on KP, KI and KD values based on the input temperature. And then my code will take a time frame, for example 2000 milliseconds, and now we're going to divide that time frame into multiple parts. 2000 divided by 16 milliseconds will give you 125. So this will be our 125 parts or 125 segments, or this is just the elements of the array. So 125 elements of the array. Now we are going to generate pattern based on this output power provided by the PID library. So output is 20%. Fill the array with 1, 0, 0. This is just an example. So the whole array, 125 element, each element is 16 milliseconds, and the whole time frame, the whole array is 2000 milliseconds. So the relay is gonna be on for this first element, then off for these two, then on. So this is just to provide the gradual heating. Then we're gonna repeat this whole process again. This is how the PID works.
Grab a pot, a bag of tea, bottle of water. Yeah. A thermometer. Hey, Governor, your experimental water is ready.
Why? Would you be a darling and mix some copper sulfate for me?
No, I won't.
Yeah, I'll do it myself.
Yeah, you do that.
Yeah, don't drink this tea. Yeah, there is probably some copper sulfate in it.
Poisonous.
Yeah,
Very poisonous. Disclaimer.
yes. All right, guys.
Science.
Bye bye. Have a good day. Great day.
Yeah. Science.